Hello, good morning, and welcome to our virtual class in quantitative methods. We are now on week two of our 2113 trimester. Okay, so our objectives for today are the following: explain statistics as science. Second is to understand the concepts of statistics and differentiate between dependent and independent variable. First, we have to know the usage of statistics. When do we use statistics? We use statistics when the number of cases that can occur are really large, so large that it would be impractical or impossible to get every sample or the entire population. Okay, so let's say, for example, a researcher from India is conducting an experiment or a research about the correlation of arm's length to one's shoe size. So basically, it would be very impractical for the researcher to make the entire population the respondents of his research. Why? Because if you are going to check in the internet, the population of India, it is more than 1 billion people. Are there living in India. So imagine how many years before you can finish your actual research or your study. So if that is the case, we can use statistics to allow us to estimate results and perhaps predict the probability of them happening in the future. All measurements contain some uncertainty and error. And statistical methods helps us quantify and characterize this uncertainty. This helps explain why scientists often speak in qualified statements. Okay, so we have to highlight this. Speak in qualified statements. So what does it mean to speak in qualified statements? Okay, so I will be giving an example here. I'll be showing you an illustration, and then the objective of this is to determine the length of this object. Okay, so you have here a straight rule, a ruler, and then using this ruler, you are going to identify the length of this object. So most of you might say that the measurement is somewhere 5.2, 5.3, or 5.18, 5.24, right? So you notice that we have different responses from different people, right? So for us to be able to have a qualified statements that would be agreeable to everyone, we could state this as the object's measurement is more than 5 centimeter but less than 6 centimeters. I believe that you would all agree with that statement, right? There. That qualified statement that we have reduces our uncertainty. Okay. But with the different responses that we have, it increases our uncertainty. And with regards to error, it says here that all measurements contain error. So it depends on the measuring device you are using, just like this one, because it has no smaller scale that is written here or included here. And at the same time, it can be human error. Okay. So another example when we say speak in a qualified statement is this. No seismologist who studies earthquakes would be willing to tell you exactly when an earthquake is going to occur. Instead, the PHIVOLCS, or your Philippine Institute of Volcanology and Seismology, issues statements like this. There is a 62% probability of at least one magnitude 6.7 or greater earthquake will hit the Philippines. Okay, so we have here the word probability. So what do we mean by probability? So these are the chances of things might or might not happen. So in this statement that we have below, there is a 62% chance that an earthquake with magnitude 6.7 or greater will hit the Philippines. So to relate that to our current situation in the Philippines, you might have heard about the big one. So you've been familiarized with this because of our TV stations reiterating about the big one. So you might be seeing Renato Solidum, who is the head of Freebox in the Philippines, of course, talking about the big one. So the big one is actually a worst case scenario of an earthquake from the West Valley Fault. It is a 100-kilometer fault that runs through 6 cities in Metro Manila and the nearby provinces. As well, tsunami is also foreseen in the scenario set by the Philippine Institute of Volcanology and Seismology. The West Valley that cuts across, okay, take note of the places that across the Bulacan province in the north to Laguna province to the south. So it was based on the details that they have that at least two major earthquakes had been recorded from the West Valley Fault in the last 1400 years. So no major movement in the fault since the 16th century, said the report on update of a 2016 report on quake vulnerability. The reason why we keep on hearing about this is to us to be familiarized with what to do and to reduce casualty and damages and loss of life. So if ever this happens, we are sure that we have our training already. We are familiarized already of what we are going to do in case this one happens anytime in the future. Modern science is often based on statements of statistical significance and probability. Okay, so studies have shown that probability of developing lung cancer is almost 20 times greater in cigarette smokers compared to non-smokers. So again, the word probability. So it says here that there is 20 times greater probability of cigarette smokers acquiring or developing lung cancer compared to the non-smokers. So there's a possibility or the probability. Okay, so it's like it doesn't mean that you are smoking, you will develop lung cancer. Okay. Next is there is a significant likelihood of a catastrophic meteorite impact on Earth sometime in the next 200,000 years. So there is a significant likelihood. Okay, so there would be a chance again, significant likelihood. There might be a chance that the Earth will experience catastrophic meteorite impact. But we are lucky enough because we will not be able to witness this. Okay, this catastrophic event in our planet. So we are no longer be walking on Earth by that time. So what do we mean by this? Scientific data rarely lead to absolute conclusions. Okay, so states here that rarely. So it's there is a small chance, very small chance that the data that we have from statistics lead to absolute conclusions, because the one we are talking about are just probability of happening. We have here an example again. Not all smokers die from lung cancer. It doesn't mean that you are a smoker, you will die from lung cancer. Some smokers decide to quit, thus reducing their risk. Some smokers may die prematurely from cardiovascular diseases or diseases other than lung cancer. And some smokers may simply never contract the disease. Okay, so others might meet petty accidents along along the road. Okay, so it doesn't mean that you are a smoker, you would die of that disease. So what does it tells us? It tells us the development of lung cancer is a probability-based event, not just a simple cause and effect relationship. Okay, so again, it doesn't tells us that if you smoke, you'll die of lung cancer. Okay, so that is not the cause and effect relationship. So you have here an illustration of how a healthy lung looks like. Okay, and then the lung of a smoker. So imagine how it looks for how many years of smoking. It would look like this. The deposit of chemicals in our lungs and our airways. Okay. There is a misconception about statistics, and that common misconception is that statistics provide a measure of proof that something is true, but they actually do no such things. Instead, statistics provide a measure of the probability of observing a certain result. Statistics are very important in science as well as technology for a number of reasons. The first reason is in research. There are various research methods that use statistics to record their results, especially when it comes to experiments in the field of science. Once a number of experiments have been carried out, statistics will show a certain result. Okay, so if you can still remember during your high school days when you have your laboratory experiments in biology, in chemistry, and in physics, right? So you are guided by your teacher and at the same time by your laboratory manual on the procedures on what to do. So you will be conducting the experiment according to the procedure, and after which you would have your results, the result of the experiment, and then you are going to discuss about it. And the last thing that we are going to do is to write our summary. Okay, so then scientists can accumulate all the statistics from each test to identify if there are any differences or changes over time. Of course, things change. Okay, so perhaps over a period of time, there would be a significant change in the data that we have. If before if the computer's memory is about kilobytes, it evolves to megabytes, and then we have the gigabyte, and then we have the terabyte and the petabyte. So you see that there are changes happening over time when it comes to this. So it is important to have statistics because it is simple and a standout way of representing results. For technology, this is important because statistics can show what the current trends are in terms of various technologies and the development of them. It is also good market research for companies that are creating various devices because statistics from areas around the country can help identify what the best device is to move forward with. So just like the evolution of mobile phones, your cell phones, before it's just a simple black and white screen or in the phone's capabilities just to call and text, but now you have a colored screen with cameras, and it can do a lot of stuff like playing games, right? and do video conferencing, instant messaging. Okay, so there. And the third one would be the value of statistics is strong because they can serve as predictions as well as probabilities in certain trends. This is especially the case in scientific experiments and studies because within a lot of scientific research, it is about trial and error and what reactions work best. Okay, so everything is a trial and error, and then whichever is the best or obtain the best result or it works best, then that is what they will adapt. Okay, so if there are professionals working towards substances for medical use, statistics can identify what works best. So just like in the vaccines that we have, okay, so we have our own convictions, we have our own decisions to make since it is our body. So you have all the datas and you would see which vaccine works best. And that is, you think, good for your body. Okay, so in relation to that as well, the use of cannabis oil, I hope that it would be legalized in our country so that it can be used on medical purposes in curing many diseases. In other countries, they are already practiced, okay, but not for recreational use. It is for medical use purpose only. A variable. So we have discussed this last week. So let us expand on this concept. A variable is a characteristic or feature that varies or changes within a study. Variable, to put in layman's statement, is something that can change or can have more than one value. Okay, so you have here our variable C and R, okay, for the formula of circumference of a circle. So C stands for the circumference and R for the radius. For this equation, 3x minus 4 is equal to 11. Our x here is our variable. The same way with this equation, y is equal to 7x plus 8. So our x and y are our variables. And then you have seen here the symbol pi, okay, which is our constant. But what is a constant? A constant is the opposite of variable. When we say constant, it is something that doesn't change. So like pi, it is always 3.14, right? The value of that. Whereas for the variables, they are the letters in the alphabet from A to Z. Any letters represents variables in an equation. Okay. There are two types of variables in every experiment. The first is the independent variable. It is the variable whose change isn't affected by any other variable in the experiment. Either the scientist has to change the independent variable herself or it changes on its own. Nothing else in the experiment affects or changes it. So we have here two common independent variables, age and time. So as we all know, there is nothing you or anybody can do to speed up or slow down time or increase or decrease someone's age because they are independent of everything else. So the world will keep on spinning even without you. Okay, so independent variable is also called regressors, controlled variables, manipulated variable, explanatory variable, or input variable. Whereas for the dependent variable, it is what is being studied and measured in the experiment. Is what changes as a result of the changes to the independent variable. An example of a dependent variable is how tall you are at different ages. So when we were young, we lean against the wall, and then with a ball pen in our hand, we would mark a horizontal line on top of our head to the wall to determine our height. And then after some time, then you compare your height, okay, and see whether you've increased your height or you become taller. So the dependent variable here, the one that is changing, is your height. And the independent variable is your age. It is the thing that we can not change. Similarly, dependent variables are also called response variable, regressant, measured variable, outcome variable, or output variable. So let us put it this way to make it easier for us to understand. So when we say independent variable, it is what you change in the experiment. Okay? Something that you can change. And for the dependent variable, is what change you observe. Okay? And again, during scientific research, there is what we call a controlled variable. It is what you keep the same and you do not change in the experiment. So let us have some examples on how we can determine an independent and dependent variable. So we have here a different popcorn brands, and we would like to know which brand pops the most popcorn kernels. So the thing that we change here or manipulate is the brand of popcorn. So you will buy different brands of popcorn. And then based from what we have here, so we are going to determine which one pops the most popcorn kernels. So our independent variable here is the brand of popcorn bag that we are going to buy in our supermarket. And the observed effect or output that we want is to know which of this pops the most number of kernels. Okay, so to have the most value for our money. Second one, in this experiment, you would like to know which brand of fertilizer helps plants grow fastest. So you add a different brand of fertilizer to each plant and see how tall they grow. So again, we choose the brand of fertilizer to use. So that is our independent variable. So we can change it, we can manipulate it. Whereas for the dependent variable, of course, what we want is to determine the plant height, the corresponding plant height given or achieved upon using these different types of fertilizer. We have here illustrative examples. So instead of varying the brand of fertilizer, this time we are going to change the amount of water to be given to the plants. Okay, so the least, just an exact amount and a very big amount of water. So our input would be the amount of water, and our expected output are the size of plant, the number of leaves, whether the plant is living or dead. So as you can see, when you give the least amount of water, still alive, it grew tall and obtained two leaves. Okay, so from one leaf, it now became two leaves. So there. So if you give it a big amount of water, you'd see that the plant died. Okay. And then if we give it a moderate amount of water, so what happened to the size of the plant? It grew taller. The number of leaves from one, it became four. It is still living. Okay. And then for this next illustrative example, we would like to know whether if this red light will affect plant growth. So what is our independent variable? The light of the color of the light that we are going to use. Okay. And then for the dependent variable, what do we want to observe? And that is the plant height. And here we have the controlled variables. So these are the things that you will keep the same. The amount of water you give to the plants will be the same. The type of soil you are going to use will be the same. The temperature with which these plants will be exposed. And will it be out for day or nighttime? Okay. And for the third experiment that we have, you're interested in how rising sea temperatures impact algae life. So you design an experiment that measures the number of algae in a sample of water taken from a specific ocean site under varying temperatures. Okay, so our objective is to determine the number of algae in a sample of water. So that is our expected output. And what would be the input? These are your ocean water temperature. Okay, so different ocean water temperature. So our independent variable is the ocean temperature, and our dependent variable will be the number of algae in the sample. So where do you put independent and dependent variables on graphs? Before we answer that, we have to know why do we have to put them on a graph? If you can still recall the lecture that we have last week, okay, so one use of statistics is to make complex data simple. And we can achieve this by representing our data in a graph. So that is why we need to know where these independent and dependent variables will be placed on a graph. Okay, so for the independent variable, it will always go to the x-axis or the horizontal axis. For the dependent variable, it will always go on the y-axis or vertical axis. So we have here an example of a graph, okay, with our vertical axis and our horizontal axis. So this study would like to achieve whether the number of hours of studying will affect your score in the exams. So our independent variable here would be your time of study. So how many times you will spend studying. And then our dependent variable, our output, expected output from this experiment would be your score on exam. So you would also see here, okay, units of measure that is enclosed in a parenthesis. This should be also indicated. And then the unit of measure for your score on an exam, which is in percentage. So if we are going to discuss this, so you would see here, as you increase the number of hours studying, okay, up to 6 hours, you'll get nearly 100% in your exam. But as you lengthen or you spend more time studying, you observe that your score, instead of going up, it decreased slightly. what could be the probable reason for that? Okay, so perhaps you are already too tired and there are already too much information that your mind or your brain can process. That's why you can no longer add more information and your brain cannot process it anymore. Okay, so that's it. So the optimal number of hours for studying or reviewing for the exam based on this graph would be up to 6 hours. So we have here on the next slide the written explanation of that graph. Okay, as you can see, this is a graph showing how the number of hours a student studies affect the score she got on an exam. From the graph, it looks like studying up to 6 hours helped her raise her score, but as she studied more than that, her score dropped slightly. So the amount of time studied is the independent variable because it's what she changed. So it's on the x-axis. The score she got on the exam is the dependent variable because it's what changed as a result of the independent variable, and it's on the y-axis. It's common to put the units in parentheses next to the axis title, which this graph does. Okay, so we are now on our summary, last part of our lecture. So we are going to differentiate again, recall the difference between independent and dependent variable. For independent variable, it may vary freely and does not depend upon changes in other variables. And it is denoted by letter X. Okay, letter X. So as you can see here in the formula, you have here an X as our variable. So this is your independent variable. So meaning this is going to be changed. And for the dependent variable, so it varies according to the changes in other variables. So it is usually denoted by letter Y. Okay? So let us try now different values. Let us change. Let us manipulate the value of X. So let us, for example, change the value of X to 2. Okay, so what would be the value of Y? So Y now will be 7 times 2 is 14 plus 8, and that's 22. So you see that when I change the value of X, there is a corresponding change in your Y. Okay, so let us assume that we make X equal to 10. So that's going to be 7 times 10 is 70 plus 8. And your Y would be equal to 78. So there is a corresponding change. If you change X, okay, you're independent, your Y changes as well. As you can see from this example, from 2 to 10 for X, your output became 22 to 78. So we have here below examples. First one, the one that we have already discussed. The time spent reviewing for an exam is your independent variable, and then the expected output would be the marks from an exam. And the last one that we have here, how many spoonfuls of sugar you put in your coffee or your tea. Okay, so the output or our dependent variable would be the sweetness of your coffee or your tea. Just like in milk tea, they would ask you about the sugar levels, right? They have 100% sugar. If you prefer too sweet, if you have a sweet tooth, you would opt for 100%. And then there you could also choose 50%, 25% sugar. So that depends on how you can tolerate sweetness. So that's it. So that ends our virtual class for today. And I'd like to know whether you have a question for me that is related to the topic that we have discussed.